Hi everyone. Today we are going to study the connection-oriented versus connectionless services provided by the network layer. Now, as we've discussed that the network layer provides you with two kind of services. One is the connection-oriented service and another one is the connectionless service. So in this video, we are going to study the connection-oriented services, and the connectionless services we will study in the next video. So let's get started. In computer networks, delivery between source and destination can be accomplished in either of the two ways, which is connection-oriented services and connectionless services. So obviously, whatever service you are using, the main goal is to transmit data from the source to the destination. So there are two ways to accomplish this transmission. One is using the connection-oriented services and other is using the connectionless services. Connection-oriented services are basically those services which require a dedicated connection, and connectionless services are those services which do not require a dedicated connection. So if we start with the connection-oriented services, the connection-oriented services define a way of transmitting data between a sender and receiver in which an end-to-end connection is established before sending any data. So in a simple language, connection-oriented services basically require that an end-to-end connection is established between the sender and the receiver before the data is actually transmitted. Now, what do you mean by end-to-end connection? End-to-end connection basically means that the transmission media through which the data is being transmitted. So the fact that the data from the actual sender to the actual receiver is successfully and reliably transmitted, this thing is taken care of, right? So from one end, that is from the sender, to the other end, that is the receiver, the data is reliably and successfully transmitted from the sender to the receiver, that is from one end to the another end, is taken care of in connection-oriented services. That is why they are known as end-to-end connection, because the connection is from one end to the other, that is from the sender to the receiver. Now, after establishing a connection, a sequence of packets from source to destination can be sent one after the another. After a connection has been established, of course, you cannot send the message in its entirety. A message is very long and big. So a better approach is to divide that message into smaller units. Those units are known as packets. So all the packets of a particular message in a sequence are then transmitted from the source to destination when the connection has been established. All the packets belonging to a message are sent from the same connection. So all the packets which belong to the same message are sent using the same connection. That is, you use a dedicated connection from the sender to the receiver, and for all the packets of that particular message or for that particular transmission, the same dedicated connection will be chosen, and no packet can go through any other path. The same path will be followed. When all packets of a message have been delivered, the connection is terminated. After all the packets have been transmitted of that particular message and there is no more packet left, the connection is obviously terminated, because you don't need to keep the packet connection unnecessarily, because keeping the connection means keeping that particular bandwidth, which will then be underutilized or wasted, because you can give that bandwidth to some other source and destination. So basically, whenever all the messages of a particular, all the packets of a particular message have been delivered, the connection is terminated. Now, in connection-oriented services, the device at both the endpoints use a protocol to establish an end-to-end connection before sending any data. So basically, there are some sets of rules for communication, right? These set of rules are known as protocols. So both the parties being involved in the communication must agree upon the same set of rules. That means both the sender and the receiver follow the same protocol for establishing an end-to-end connection before any actual data is sent in case of a connection-oriented service. Now, connection-oriented service usually has the following characteristics. What are the characteristics of the connection-oriented service? The network guarantees that all packets will be delivered in order without loss or duplication of data. So the first service is that the network guarantees the fact that all the packets of a particular message will be delivered using that dedicated connection to the receiver and in proper order, in the order in which they are meant to be received without loss. First of all, the packets will not be lost, and then there will be no duplication of data. Now, what do you mean by duplication of data? Duplication basically means that the same packet is being transmitted more than once, which is not required. You only need a packet to be received once by the receiver. So if it is being received more than once, that is known as duplication of data, and such packets are known as duplicate packets. So that is of no use, that is wastage of bandwidth. So the network, in case of connection-oriented services, guarantees that first of all the packets will be delivered in proper order or in proper sequence, and then without any loss or duplication of data. Further, by in order, I mean the same sequence in which they have been transmitted. Say, for example, if packet number 1 was transmitted first and packet number 2 was transmitted later, then at the receiver's end, packet number 1 will only be received first and then packet number 2 will be received. So that means the packets will be received in the same order in which they were transmitted. It will never happen that the receiver will receive packet number 2 before packet 1. No, this will never happen. So this is known as in order delivery of the packets. So the network basically guarantees in order delivery. It ensures all packets are delivered. It ensures they are delivered without any loss or duplication of data. Second, only a single path is established for the call and all the data follows that path, right? So when I say dedicated path, that means one single path which is dedicated for that particular sender and receiver only. So that means only a single path is established for the call, and then all the packets or all the data of that particular message follows that path only. Now the network guarantees a minimal amount of bandwidth, and this bandwidth is reserved for the duration of the call. So the network, also one more good thing about this is that the network guarantees that it will use minimal amount of bandwidth. Bandwidth is a resource which is required by all the parties interested in communication. So if for the communication of one set of sender and receiver, it uses minimal amount of bandwidth so that the rest of the senders and receivers can also use some portion of the bandwidth, and this bandwidth is then reserved for the duration of that call. So this particular bandwidth which has been used for that particular sender and receiver will be reserved for the entire duration of the call and cannot be used by any other sender or receiver. So if the network is busy, right? That means if that particular dedicated connection is being used by one sender and receiver and some other future calls are made to that particular connection, then though they are refused. That means that bandwidth is not allocated to any other sender or receiver if it is being used by one particular sender and receiver, because it is dedicated. That means it is meant only for that pair of sender and receiver. So it is quite similar to a telephone call wherein you establish a connection. You dial up somebody's number and a connection is send a request for connection establishment. The moment the other person picks up the phone, a connection is established. Then you start talking to that person. That means your messages are being delivered, and this is a dedicated connection. That means no other person except you and the except you two. That means the one who has dialed and the one who has received. No third person other than the two of you can use that connection for that duration of time when you are transmitting or when you are talking. So this is quite similar to the telephone connection, the conventional telephone connections that we had at home earlier. So this is quite similar to that. So you can relate the connection oriented services to the dial-up telephone networks, right? Now, connection-oriented services are sometimes known as reliable network. There is no surprise if I call them reliable network, because they are reliable. They are providing you reliability in terms of the fact that all the packets will be delivered without any loss. There will be no duplication of data. The packets will be delivered in the same or received in the same order in which they were delivered. Hence, we can say that they are reliable network service. Of course, as I said, because it guarantees that data will arrive in proper order or in proper sequence. Single connection for entire message facilitates acknowledgement process and retransmission of damaged and lost frames. Since a single or dedicated connection is being used between the sender and transmitter, so just in case any packet is not received by the receiver which has been sent by the sender, so what the receiver will do, after a particular time interval, it'll not send an acknowledgement for that particular packet, because it did not receive it, though it was sent by the sender. So what the sender will do, after waiting for a particular interval of time, when it finds that it did not receive the acknowledgement from the receiver, then it will retransmit that packet, assuming that the receiver did not receive it, because obviously the receiver does not send an acknowledgement only for those packets which it did not receive. So that means it ensures that all the packets are being transmitted to the receiver without any loss. Connection-oriented transmission has 3 stages, and this is known as your handshaking mechanism. This is also known as 3-way handshaking. So the first is connection establishment. Now, first of all, what do you need to do to transmit data using a connection-oriented transmission or a connection-oriented service? You need to establish a connection first of all, right? You need to establish a dedicated connection between the sender and the receiver. So in connection-oriented services, before transmitting data, the sending device must first determine the availability of the other device to exchange data, and connection must be established by which data can be sent. So of course, before even you can establish a connection, the sender must ensure that the receiver is ready to receive or not. It may be busy with some other device. So the sender has to first of all ensure or determine the availability of the other device. Just like in case of a dial-up telephone connection, when you dial a number and you find a busy tone, you wait for some time and then you again dial the number. So that means if the other person is busy with someone else, that person is not available for connection establishment, hence you would wait. So similarly here also, the sender would first check for the availability of the other device, and only then it would request to establish a connection and exchange data. Then the connection establishment requires 3 steps. What are these 3 steps? First, the sender computer requests the connection by sending a connection request packet to the intended receiver. Now, if the receiver is available for connection establishment, the first thing that the sender will do will request for the connection. How will it request for the connection? By sending a packet which is known as connection request packet to the intended receiver. Okay. After the receiver receives the connection request packet, the receiver computer returns a confirmation packet to the requesting computer. So when the receiver computer returns the confirmation packet, that means the receiver is ready for connection establishment. And when the sender receives the confirmation packet, then the sender computer returns a packet acknowledging the confirmation. That means the sender acknowledges the fact that it has received a confirmation packet from the receiver, and then the connection is finally established. Then the second step after connection establishment is your data transfer. Now, after the data has been established, connection has been established, you would do what you were actually waiting for. That is, you would transmit your data. So after the connection gets established, the sender starts sending data packets to the receiver. And the third step, after all the data packets have been sent to the receiver, now you do not need the connection anymore. So what would you do? You would obviously terminate the connection. So the third step after the data transfer has been finished, then you would do connection termination. So after all the data gets transferred, the connection has to be terminated, because that bandwidth will then be used by some other sender and receiver pair. So connection termination also requires a 3-way handshake, right? So just like we saw that there was a 3-way handshake in case of connection establishment, similarly here also there is a 3-way handshake in case of connection termination. So this three-way handshake involves the sender computer requesting disconnection by sending a disconnection request packet. Again, here also the sender computer is the one which will be requesting for disconnection. So how does it request for disconnection? By sending a request packet which is known as disconnection request packet. Then the second step in the three-way handshaking is the receiver computer confirms the disconnection request. So when the receiver computer receives the disconnection request packet, it confirms it, right? And when it is confirmed, the sender computer returns an acknowledgement packet that okay, it has received the disconnection request packet. Okay, that it has acknowledged the fact that the receiver computer has confirmed the disconnection request. And finally, the sender computer, when it receives a disconnection confirmation packet from the receiver, will, and then after sending an packet acknowledging the disconnection confirmation packet, will then send a confirmation with the help of an acknowledgement packet. So the receiver computers, basically what it does on receiving the connection termination request, which is known as the connection termination disconnection request packet, it will send a disconnection request, will confirm the disconnection request, and the sender computer returns a packet acknowledging the confirmation for the disconnection, and hereafter, after this, the connection is terminated. So this is how the connection oriented services work.